Hello future toppers. So now we are going to move ahead with the previous year practice question session for year 2023 to 24 of the chapter Current Electricity. So without delay, let's begin the MCQ questions. The first question is, if the electron in H2 atom makes 6.25 10 to the power 15 revolution per second, the current is 1 ampere, 10 to the power minus 1 ampere, 1 milliampere, 1 microampere. So let us see the solution of this question. You take your own time, just pause that video and try to solve by yourself. The solution is I is equals to, we know, Q by 2 pi into omega. How this value comes? So we know that the formula of a current, that is I is equals to Q by T and T is equals to 2 pi by omega. So if I put this value over there, we get the value of Q by 2 pi by omega, which is multiplied here. This value comes in the nature. If I just put all these values, we get this particular terms. Now after solution, we get the value of 10 to the power minus 3 ampere. That means the correct answer for this question is 1 milliampere. I hope you also get the same answer. Moving ahead with the next question, which a current of 1.6 ampere is flowing in a conductor. The number of electrons flowing per second through the conductor is 10 to the power 9, 10 to the power 19, 10 to the power 16 and 10 to the power 31. So, let us see the solution of this question. We know that the value of I is equals to NQ by T. So, N by T is equals to I by Q. We just put this value and get the value 10 to the power 19, which is option number 2. I hope you get the same. Moving ahead with the question number 3. So next question we have, a current flows in a wire of a circular cross section with the free electrons traveling with drift velocity vector v. If an equal current flows in a wire of a twice of the radius, new drift velocity is. We have an option vector v by 2, vector v by 4, 2 vector v. Let us see the solution of this question. So we know that the drift velocity is directly proportional to the 1 by r square. That means r2 is equals to 2r. From the equation I is equals to NEAVD, where VD is equals to I by NEA. So here A is the area by which we can calculate this value. So V1 by V2 we can calculate R2 square by R1 square. Put all these values here, we get the answer V1 by 4. According to this, the correct answer for this question is option 3. Moving ahead with the next question, a copper wire of a cross-sectional area 2 mm square, resistivity is equals to 1.7 10 to the power minus 8 ohm meter, carries a current of 1 ampere. The electric field in the copper wire is 8.5 10 to the power minus 5 volt per meter, 8.5 10 to the power minus 4 volt per meter, 8.5 10 to the power minus 3 volt per meter, and 8.5 10 to the power minus 2 volt per meter. That is, moving ahead with the solution part. We know that the area is equals to 2 mm square is a given. The resistivity rho is equals to 1.7 10 to the power minus 8 ohm meter is given. And current 1 ampere. So we apply the Ohm's law, which is V is equals to IR. We know that E is equals to V by D. So ED is equals to IR. Also, R is directly proportional to the I. So, we know R is directly proportional to the L and inversely proportional to the E. From here, we can say that R is equals to SL by E. From equation 1 and 2, we can say that ID is equals to ED is equals to I SL by E. We just put all these value over there and get the value of E, which is 8.5 10 to the power minus 3. That means the correct option for this question is option 3. Hope you understand the process. Moving ahead with the next question. A wire of a resistance capital R is cut into 4 equal parts and they are bundled together side by side to form the thicker wire. The resistance of the bundle is R by 60, 0.5 R, 2 R and 4 R. Moving ahead with the solution part. So we know that for a parallel resistance, for a parallel wire, if we just cut the resistance into 4 equal parts and bundle together, so they will make a parallel combination. So for parallel combination, we know this formula. We just put all these value over there and get the result. That is R effective is equals to 1 by n square. So here the part which is a cut is a 4. So 1 by 4 square times R. So this will be R by 60. That means the correct option for this question is option 1. Moving ahead with the next question. 4 wires made of same material have a different length and radii. The wire having more resistance in the following is L is equals to 100 centimeter and R is equals to 1 millimeter. L is equals to 50 centimeter and R is equals to 2 millimeter. L is equals to 100 centimeter, R is equals to half millimeter. L is equals to 15 centimeter and R is equals to half millimeter. Let us move with the solution part. So we know R is directly proportional to the L and inversely proportional to the R square. That means if we put all these value, we get the formula. We get the result, that is L is equals to 100 centimeter and R is equals to half of millimeter. Next question we have 4 conductors of a same resistance connected to from a square. If the resistance between the diagonally opposite corner is 8 ohm, the resistance between two adjacent corners is. We have these options. Let us move with the solution part. So, if capital R is the resistance of each side, then given 2R into 2R by 2R plus 2R. This is a parallel combination. So, 8 ohm is a given. So, R is equals to 8 ohm. Hence, we can say that again R parallel for the first combination, that is a 3R by 4. So, R prime will be 6 ohm if we just put the value of R over there. Hence, the correct option is option 4. Next question we have a wire of a resistance 12 ohm is bent in a form of a circle. The effective resistance between the ends of any diameter. We have these options. Moving ahead with the solution part. So R1 is equals to R by 2 pi R into R theta. That means we can say R theta by 2 pi. If we just put all these value of R, small r to pi minus theta, like this. So here theta is equals to 180 complete and we just bend a little bit. So we have to find the value for R theta. So R2 will be R small r 2 pi minus theta divided by 2 pi. R equivalent we can calculate from the parallel combination. We just put all these value over there and get the result. So R by 4, R is given 12. So 12 by 4, 3. According to this, the correct option is option 1. Next question we have. A technician has only 2 resistance coils. By using them singly in series or parallel, he is able to obtain the resistance 1.5, 2, 6 and 8 ohm. The resistance of the 2 coils are 3 and 5 ohm, 1 and 7 ohm, 2 and 6 ohm, 4 ohm each. Let us move with the solution part. Verify the maximum and minimum resistance with given resistances, maximum in series and minimum in parallel. So 2 plus 6 is 8 and the parallel 1.5 each. That means we can say the correct answer for this question is approximately 3. The next question we have the equivalent resistance of two resistances in series is 5 ohm and 1.2 ohm in a parallel. The higher resistance is 12 ohm, 3 ohm, 1 ohm and 4 ohm. Let us see the solution of this question. So, we just take the parallel combination and the series combination for this resistance. So, we will get 12 and 5. If we just add the parallel combination and series combination, we will get this. So, if we just put the value of R in 3, we get the same answer. That means the second option is the correct answer. Next question, we have a resistance of a wire is 2 ohm. It is drawn in such a way that it experiences a longitudinal strain of a 200%. Its new resistance is 6 ohm, 8 ohm, 12 ohm and 18 ohm. Let us see the solution of this question. So, if a wire or a conductor is stretched or elongated or drawn or twisted, then the volume of a conductor is a constant. That means R is equals to rho L by A into L by L. We just solve this particular term and get the result R is directly proportional to the L square. Hence, we can say that the strain is equals to delta L by L. 200 by 100 is equals to 2, which gives the delta L is equals to 2L. L2 is equals to 3L. So we just put all these values together and get the result 18 ohm. Hence the correct option for this question is 4. Moving ahead with the next question. A carbon filament has a resistance of a 120 ohm at 0 degree centigrade. What must be the resistance of a copper filament connected in series with carbon so that combination has same resistance at all temperatures? Alpha is carbon is equals to 710 to the power minus 4 coulomb per degree centigrade, and alpha copper is equals to 410 to the power minus 3 per degree centigrade. So the solution for this question, firstly we see the options for this. So these are the options. Solutions are here. Just pause that video and do solve by yourself and just match your answer. So the solution for this question is R1 alpha 1 is equals to R2 alpha 2. We just put all these values together and get the result, which is a 120 ohm. So RC will be 120. We just put all these values together and get the result 21 ohm. Hence the correct option is option 2. I hope you get the same. Next question we have dimensions of a metal block 100 centimeter into 2 centimeter into 2 centimeter. The ratio of resistance between square faces and rectangular faces is, this is a diagram and we have these options. The solution we have, just do the nomenclature of each particular terms, like here the term is C, B, D, A, B, C, D on that particular terms, and the length will be like length L and the width will be H and the height will be H. Okay, these are the nomenclature which we will do generally for this solution. So we know the formula RAB is equals to rho L by B cross H. RCD is equals to rho B by L into H. So RAB by RCD is equals to rho 100 divided by 2 into 2 is equals to 100 into 2 divided by rho. We just get the ratio 2500 ratio 1. For more elaboration, I just want to elaborate this term a little bit more. Like we know the formula of R, which is a rho L by A. So here the area, if we just take the AB. So for the case of AB, this will be width into height. If I just take this one. So for this scenario, we just take area, breadth into height. And for the case of a CD, we just take length into height for the area. I hope you understand and getting my points. Moving ahead with the next question. The equivalent resistance between A and B if the each resistance is equal to 20 ohm is. The resultant will be 10 ohm, 32 ohm, 20 ohm and 26.67. Each have a resistance to 20 ohm. Let's move at the solution part. So, we know that these three combinations like R, firstly we will take, if this will be an R, an R. So, after this parallel combination, we will get the R by 2 over there. Then we have again R. I'm just assuming firstly this will be R and the final we will put the value of R is equals to 20. So, a little bit solution, R and R by 2. These both are in the series combination and again R by 2. These in series and R in the parallel. So we will get this particular phenomenon. Now after solution, R and R by 2 in the series, we get 3R by 2 into R divided by 5R by 2. That means 3R by 2. 3R by 5. We just put the value of R over there and get the result, which is 32 ohm. According to this, the correct answer for this question is option 2. Hope you also get the same answer. Moving ahead with the next question. If each conductor has a 9 ohm resistance, the resistance between D and E is. We have this diagram. Again, we will just take, and options are these. We just assume each have a resistance R, and in the final we will put the value of a 9 ohm. So equivalent circuit is, we know if we will take the value of like B and C, this value and this value. So they have a same current, that means we just add together. And simply this 2R and R will be in the parallel combination, so we can solve this particular term and get the result like a 2R and R. This will be in the parallel combination, so we will get this particular term and this normal R and R we can add up together. Moving ahead with the next question. The effective resistance between A and B in the given circuit is. We have this circuit. From saying this will be a little bit hard, but it's easy. So we have an option 20 ohm, 7 ohm, 3 ohm, 6 ohm. Moving with the solution part, just pause that video and try to do yourself firstly. So the solution is equivalent circuit is, if we solve this particular terms, so as you can see over there, this 2 ohm and 2 ohm and again 2 ohm. These are in the series combination. We just solve this particular term and get the 6 ohm. 6 ohm and 3 ohm becomes in parallel. So we will get again 2 ohm. Again 2 ohm, 2 ohm and this 2 ohm. This again is the parallel. So after solution, we will get at the last 2 ohm. If we take this, so 6 ohm. 6 ohm and 3 ohm becomes in a parallel. 6 ohm and 3 ohm becomes in a parallel. So this will be 2 ohm. That means here after solution we will get 2 ohm. So 2 ohm, again 2 ohm and 2 ohm. So this will become 6 ohm and again 6 ohm and 3 ohm we will get 2 ohm. So that value we will receive over there. After a little bit solution we will get this value like a, so 2s and 2. This will be 6 as I told you. So this is a final solution for this like 2 ohm and 2 ohm. And lately on 2 ohm is a series, so we will get the 6 ohm, which is option number 4. The next we have the effective resistance between A and B in the given circuit is. So again, as I told you, these are the options. Just pause that video and try to do yourself. Very simple question these are. So moving ahead with the solution part. And resistance are not considered because they are not connected by any circuit. So we will take this particular terminal. So 2 ohm and 2 ohm. If we are just taking these terminals, so the resultant will be give 6. Now 6 and 3, these are in the parallel combination. So 6 and 3 ohm, as we can see here, these three are in the series combination. So we will get 6 over there. And 6 ohm and 3 ohm again in the parallel combination. So we will get 2 ohm. That means at the final we will get 2 plus 2 plus 2. That means we will get 6 ohm. This is the option number 3. Hope you understand, students. If there is any problem, you can ask in the comment section. Next, we have an effective resistance between A and B in the given circuit. So we have a now new circuit is this. So we have our options are these. Moving with the solution part. Equivalent circuit is, if we solve the circuit. So 3 ohm and 6 ohm are in the parallel combination. We get this value. Now 10 ohm and 30. Again this will be parallel. So we will get the final answer 7.55. According to this, the correct option for this question is option second. Hope you also get the same answer. Next question we have the equivalent resistance across XY is. This is a very common circuit, but there will be a logic behind the circuit. We have these options. Moving with the solution part, equivalent circuit is this. Now, after solution, as you can see, if we just take the little bit comprehension of the circuit, so we will get easily the circuit like R and R, these becomes R in the series combination. So we will get 2R and this for 2R, 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 2R and 2R. This will be in the parallel combination. So what we will get at the final? We will get 4 times of a 1 by 2R terms. That means 2R by 4. That means R by 2. According to this, the correct answer is option 3. Hope you also get the same result, and this is a quick phenomena after for the circuit solution. Moving ahead with the next question, we have a 20th question. An ammeter is connected as shown in the diagram. Ammeter reading is. So, the options are these. Let us move with the solution part. R effective, as you can see, this will be in the opposite direction, but this will be, you can see easily, R by 5 over there. So, I is equals to 5E by R. That means I prime is equals to 2E by R. That means the correct option for this question is 1. Moving ahead with the next question, if the current through 1 ohm resistor is 2 ampere, the ammeter reading is. We have this circuit. This is a very very impressive circuit, as you can see over there. The little bit phenomena over there, which is a trick over there. So we have an options 1 ohm, 2 ohm, 1.5 ampere, 1 ampere, 2 ampere, 1.5 ampere and 2.5 ampere. So let us move with the solution part. The total circuit passes through the upper loop is 1 plus 2. As you can see over there, these both in the series combination. So directly we will add together and get the 3 ohm. Similar we will do with that and get the result 7 ohm. So R effective will be IR. This will be 3 into 2 times, that is 6 volt. So IA V by R 6 by 6 is equals to 1 ampere. Hope you understand the previous question. Now moving ahead with the next question, which is 22. Two resistances made of the same materials having length 3 cm, 5 cm and radii 1 mm, 3 mm and are connected in the series to a cell of e.m.f 16 volt. And negligible resistance potential difference across shorter wire is 2.5 ohm, 2.5 volt, 13.5 volt, 16 volt and 8 volt. So these are the options of this question. Let's moving with the solution. Do pause that video and try to do yourself. So we know that formula for this question is a V is equals to IR. I is equals to 5L by A. We know V is directly proportional to the 1 by R square. So we'll just solve this value and get the result. Like a V1 by V2 is equals to 27 by 5. So V1 is equals to 27 by 32 into 16 and get the result 13.5, which is the option 2. Hope you understand the process of the solution. If there is any doubt, you can ask in the comment section. Moving ahead with the next question. In the circuit, each resistance is equals to 12 ohm. The potential difference between A and E is. Again, this is a very impressive circuit, and this kind of a circuit are really coming in your board exam. So this is an important question for your board exam also. Now the options are 12 volt, 2 volt, 12 volt, 2 volt, 4 volt and 6 volt are there. Moving ahead with the solution part. So V1 is equals to IR1, which is a half of this 12 volt. We get the 6 volt. V2 is equals to IR2, which is 6V. So 24 ohm is equals to approximately equals to 12V. We get the value of from here half ampere. That is the option number 4, which is the right answer. Next question we have, in the circuit each resistance is equals to 12 ohm. The equivalent resistance between A and B is 6 ohm, 4 ohm, 8 ohm and 1 ohm. So we have to calculate the equivalent resistance between A and B like this. So the solution part is, we know the value of RAB. So if I'm just talking about the AB particular point, so 12, because each have a resistance of 12. So this R1, R2 and R5, as you can see, this is because here the potential is equipotential. So we just disconnect the circuit and we have these kind of a resistance, which is R in the parallel combination. So we will get RAB is equals to 4 ohm. According to this, the correct option is option number 2. So internal resistance and EMF based question. Now we are going to solve. So 25th questions are, the EMF of a linear cell is a 1.08 volt. When the terminal are connected to the resistance of a 3 ohm and the potential difference across the terminal is found to be 0.6 volt, then the internal resistance of the cell is dash 1.8, 2.4, 3.24 and 0.2. Let's move with the solution part. V is equals to E minus IR. That means V is equals to IR. We just put all these values together and get the result 0.2 ampere. This is the value of I, which we put the main formula, which is V is equals to E minus IR, and get the result is. So what formula we will use over there? V is equals to E minus IR. Next question we have, a cell of EMF E is connected across a resistor capital R. The potential difference between the terminals of the potential of the cell is found to be V. The internal resistance of the cell is, we have an options. First, these kind of options we have. Let's do pause this video and try to solve by yourself. And let's match with your answer with my answer. The solution we have, V is equals to IR, we know. We just put the value of I over there and get the result. R plus R by R is equals to E by V. Or we can say 1 plus small r by capital R, which is the internal resistance divided by the external resistance, is equals to E by V. We just put all these values together and get the value of R. That means the correct answer for this question is option 3. Hope you also get the same result. Moving ahead with the next question. When two equal cells are connected neither in series or in a parallel combination, 2 ohm resistor, they send the same current through it. The internal resistance of each cell is 2 ohm, 1.2 ohm, 12 ohm, 21 ohm. Move ahead with the solution part. I is equals to E total divided by R total. We just put this value like I. Series is equals to I in a parallel combination. We just put all these values together and get 2E by R plus 2R is equals to E by R plus R by 2. That means 2R plus R is equals to R plus 2R. R is equals to R by is equals to 2 ohm. That means the correct option for this question is a 1. I hope you understand this little solution which I did over there. For more explanation, we just try to solve like 2R. This R, when this will become here, this will become R. Now here small r, I'll just send it out here. So capital R is equals to small r, which is given in this question is a 2. Hope you understand now. Moving ahead with the next question, which we have 28th question. A cell of EMF 2 volt delivers current equals to 20% of the maximum current it can produce through a resistance 4 ohm. Its internal resistance is, we have an options 0.1 ohm, 1 ohm, 0.5 ohm, 1.5 ohm. So let's move with the solution part. Maximum current I is equals to E by R. That means 20.1 into E by R is equals to E R plus R. Now we just put all these values together. We get the value of 1 by 5R is equals to 1 by 4 plus R. Here we can get the value of R over there, which is equals to 1 ohm. Now moving ahead with the next question, because this option is correct too. The next question we have, the potential difference across terminal of a cell is found to be 29 volt and 28 volt respectively when it delivers a current of 1 ampere and 2 ampere respectively. The e.m.f and internal resistance of the cell are respectively. We have these options. Let's pause this video and try to do yourself. Now we move on the solution part. So we know that the potential formula for this question is V is equals to E minus IR. We just put all these values together and get the result R is equals to 1. Now this R is equals to 1 ohm. We just put the formula V is equals to E minus IR and get the value of E. That means we have a 30 volt and 1 ohm. According to this, the correct option for this question is second. Hope you understand the question solution. Next, we have two cells of the same e.m.f are in series with the external resistance R. The internal resistance R1 is greater than R2. The potential difference across the first cell is found to be 0. The value of R is R1 plus R2, R1 plus R2 by 2, R1 minus R2 and R1 minus R2 by 2. Let's move with the solution part. So, V is the voltage across any one cell I is equals to 2E by R1 plus R2 in the internal plus external R. Voltage given across first cell is 0. So V is equals to E minus IR. We will apply it over there. E minus R1. R1 2E times divided by R plus R1 plus R2 is equals to 0. From here we can calculate the value of R, which is the R1 minus R2. Hope you understand the solution of this process. Hence, the correct option for this question is option 2. Next question, we have three cells, each of e.m.f 1.5 volt, are first connected in the series and then parallel to the external resistance. The current obtained in two cases are respectively 1 ampere and 0.6 ampere. Calculate the external resistance. 1.25 ohm, 3.26 ohm, 4.125 ohm and 2.235 ohm. We have solutions. In the series combination, we apply this formula, and for the case of a parallel, we just apply the formula here. So we have two equations. Solving first and second equation, we get the value of R and capital R, which is external resistance. Hence, the correct option for this question is option 3. Hope you understand the solution. You can do pause and see the solution process again. Next question, which is we have a battery of 4 cells in series, each having an e.m.f of 1.5 volt and internal resistance 1 ohm are connected in series with an ammeter, a coil of resistance 2 and a filament lamp. If the ammeter reads 0.5 ampere, the resistance of the filament lamp is 4 ohm, 6 ohm, 2 ohm, 12 ohm. We have the solution. I is equals to E divided by R plus R plus R. We just calculate the value of I from here. X is the resistance of the filament. So, we just put this value and get the value of X, which is 6 ohm. According to this, the correct option for this question is option 2. Moving ahead with the next question, 12 cells of each e.m.f 2 volt are connected in series. Among them, 3 cells are connected wrongly. Then effective e.m.f of the combination is, we have these options. Now, for the solution part, we know that E is equals to N minus 2M times E. So, 12 minus 6 times E. we will get E is equals to 12 volt. Hence, the correct option for this question is 12 volt. Next, we have a 20 cells, each of a 6 volt are connected in series. The EMF of the combination is found to be 96 volt. How many cells are connected wrong? We have these options. Moving ahead with the solution part. So again, for the combination of a wrong cell, we formula applied E is equals to N minus 2M times E. Here, the N is a number of a cell, M is the actually wrong combinations. So, find two wrong combinations over there. In the following diagram, the potential difference across 6 volt cell is. We have these options. Moving ahead with the solution part. So, I is equals to total EMF divided by total resistance. We just saw this process, we get the value of I. We know the value of V is equals to E minus IR2. We just put all these values together and get the value of a V. Hence, from this, we can say that the value of a V is equals to 8.4 volt. According to this, we have a correct option, which is a 4 option. I hope you understand the following processes and the process of a solution. So for today's class, this much is only. Take care of yourself, revise this topic, and thank you for watching this video.